Welcome to section 1.8. Today is going to be a lot of review. All of the formulas we'll be working with are the same as they were last semester. The only thing different is the way we're defining the natural log. Last semester we defined ln x to be the inverse of the function e to the x. This semester we're defining ln x in terms of an integral. So we're defining ln x to be the integral from 1 to x of 1 over t dt. Now, geometrically, what that is, if x is bigger than 1, then ln of x will be the area underneath this curve 1 over t between 1 and x. And I have that area function graphed in dotted red. That's ln x. And if x is less than 1, but of course greater than 0, like a half, then ln x will be the negative of the area of that red shaded region, because when you integrate from 1 to 1/2, you're integrating backwards. All right, so let's just jump right in and do some calculations. Start with a simple example, the derivative of e to the 2x squared plus 5x. Here's our formula over here. The derivative of e to the u is u prime e to the u. So this is 4x plus 5 e to the 2x squared plus 5x. Now I wrote that down incorrectly on purpose. Hopefully you can catch what I did. What I did was I didn't use parentheses. So we need parentheses around that 4x plus 5 because this whole thing is multiplied by that exponential. Okay, the next one, I'm going to verify a formula in your Bible for you. So formula 3 right here is a Bible formula, and I'm going to verify in the case that k is 1. And hopefully this will convince you that you don't want to do this by hand every time. So take this 2 out, that's a typo. The integral of secant x dx. The trick is to multiply by secant x plus tangent x over secant x plus tangent x. So I'm multiplying by 1, but what that gets me is the ability to do a u sub. So now I'm going to let u be the denominator. Secant x plus tangent x du is, well, the derivative of secant is secant x tangent x plus the derivative of tangent is secant squared x dx. So great, that's what I have in the numerator. So this is the integral of 1 over u du, which is ln of the absolute value of u plus c, which is ln of the absolute value. U was secant x plus tangent x plus c. And there it is. Okay, let's do another u sub. Here I'm going to let u equal ln x. Du is 1 over x dx. Remember the rule for the derivative of natural log. It's right up, well, actually, I have it right here. The derivative of ln of u is u prime over u. All right, so I don't need to do any modification because I have a 1 over x dx, and this integral is u to the 4th du, and let's change our limits. When x is 1, that's the old limit. The new limit, we want u equal ln of 1, well, that's 0. So our new lower limit is 0, and when x is e squared, u is ln of e squared, which is 2. So that's our new upper limit. So now we integrate 1/5 u to the 5th, straight bar, 0 to 2. Don't go back to x's because we changed the limits, 32/5. All right, let's solve an initial value problem. That means find the function y. So we're given the derivative of y. The way we're going to recover y is to integrate. So y is the integral of 1 over t ln 2t dt, and you do need that y there in front. That's mandatory. So in order to integrate, we're going to do a u sub. U is ln of 2t. Du is 2. That's the derivative of my inside function. So 2 over 2t dt, which is just 1 over t dt. All right. So this becomes the integral. I have a 1 over t dt, that's taken care of by the du, and what's left is a 1 over u. So 1 over u du, that's y. That's ln of the absolute value of u plus c, So y is ln of the absolute value of ln of 2t plus c. So there are two natural logs there. Step 2 is to find c. We're going to use the fact that y of e over 2 is 1. So on the left, I put a 1. That's why you had to write the y there. And on the right, everywhere I see a t, I put in an e over 2. So that's ln of the absolute value of ln. 2 times e over 2 is e plus c. Okay, well, ln of e is 1, and ln of 1 is 0. So that tells me c is 1. So this implies that c equals 1. That's really sloppy, so I'm going to try and clean that up a little bit. This is 1. Well, I could just write a new line, but I'm not going to. I'll just leave it like that for now. Step 3 is to put steps 1 and 2 together. We want to answer as a function. So y is ln of the absolute value of ln 2t plus c, but now we know what c is. C is 1. And so that's our answer. Okay, last page is a review of calculus with a base different than e. So exponentials, a to the x, and logs that are not natural logs, log base a of x. So here are the formulas that we learned last semester, and let's just jump right in and use them rather than talk about them. The derivative of 2 to the x. Well, that's this formula right here. It's ln of 2 times 2 to the x. And if you're curious about why, I have an explanation in red that you can read. All right, next one, d by dx of log base 3 x squared plus 1. Well, I don't see a formula up here that would handle that, but I do see a change of base formula. So what we're going to do is change the base. So we're not going to take the derivative yet. This is d by dx. Change this to natural log, and then use a formula that we know. So this is ln of x squared plus 1 divided by ln of 3 by the change of base formula. All right, so that's all I did was change the base. I didn't take the derivative, and that's not times. That's d by dx of this function. Okay, now we can take the derivative using d by dx of ln of u is u prime over u from the first page. Now, don't use the quotient rule. ln of 3 is a constant. So this is 1 over ln 3, and then we want the derivative of ln x squared plus 1. Which is 2x over x squared plus 1. And then I can either multiply out front by 1 over ln 3, or I can put parentheses here and put the ln 3 downstairs inside of this fraction. All right, last one, an integral. I'm going to do a u sub here. U is cos 5t. du is negative 5 sine 5t dt. I have a sine 5t dt, so I'm going to divide both sides by negative 1/5. Remember, I want a separate line for that. Sine 5t dt. So now I'm ready to replace things. I'm going to put my negative 1/5 out front, integral sign. What I'm left with is 3 to the u du. And I'm going to change the limits. When t is 0, u is cosine of 0, which is 1. And when t is pi over 10, u is cosine of 5 pi over 10 is pi over 2, which is 0. I could leave the integral like that and integrate, but what I'm going to do just to practice properties of integrals is I'm going to switch the limit so I have my lower limit on the bottom, 0 to 1, 3 to the u, du. And when you do that, when you change the limits, you introduce a minus sign in front of the integral. So this negative 1/5 becomes a positive 1/5. So these are the same thing. You didn't have to do that, but I am. All right, now I can use the formula I have for the integral of a to the x up at the top of the page, this formula right here, to integrate. So I'm going to get a 1 over ln 3 So I'll have 1 over 5, and then I'll also have an ln3 in the denominator. 3 to the u, straight bar, 0, 1. That's 1 over 5 ln 3. 3 to the 1 is 3, and 3 to the 0 is 1. 3 minus 1 is 2, so 2 over 5 ln 3. And that is the end of this section.